In this lesson, I'll give you an overview of our chapter on web apps and HTML5. As discussed on this web apps overview page in the API guides of the developer's website, there are two ways to deliver an application on an Android device. As a client-side app developed using the Android SDK, as we've been doing during this course, or as a web application from a server using web standards and access through a web browser. And there's a third approach, which is a mixture of these two. You can develop a client-side Android app that embeds some web pages using a web view in your Android app layout. In the next lesson, we'll look at the code for an Android app with a web view embedded in it. Figure 1 in this page shows how you can provide access to your web pages from either a web browser or your Android app with a web view. And notice a difference between the two. At the top of the display in the browser, on the left, you see the browser search bar. And at the top of the display in the WebView version on the right, you see an Android action bar. Now, you shouldn't develop an Android application simply as a way to launch your website. The web pages you embed in your Android application should be designed especially for that environment. You can also define an interface between your Android application and your web pages that allows JavaScript code in the web pages to call APIs in your Android application, thus providing Android APIs to your web-based application. In developing web apps, you need to consider how your web pages appear on different kinds of screens. And there are two basic factors to account for. First, the size of the viewport and scale of the web page. The viewport is the area in which your page will be displayed. When the browser loads a web page, the default is to load the page in overview mode, which provides a zoomed out perspective of the web page. You can override this for your web page by defining the default dimensions of the viewport or the initial scale of the viewport in your web page HTML. You can also control how much the user can zoom in and out of your web page. However, when your web page is rendered in a web view, the page loads at full zoom, not in overview mode. So it appears at the default size for the page instead of zoomed out. The second factor to consider is the device's screen density. The screen density, which is the number of pixels per inch on an Android-powered device, affects the resolution and size at which a web page is displayed. There are different density categories, such as low, medium, and high. The Android browser and web view compensate for variations in screen density by scaling a web page so that all devices display the web page at the same perceivable size as a medium density screen. To provide the best visual representation on all screen densities, you should control how scaling occurs by providing viewport metadata about your web page's target screen density and providing alternative graphics for different screen densities, which you can apply to different screens using CSS or JavaScript in your web page HTML. This page on targeting screens from web apps provides a number of examples, descriptions, and sample code for various situations. HTML5 is the latest improvement in the markup language for structuring and presenting content on the World Wide Web and is the successor to HTML4. Its standard definition has recently been stabilized by the W3C consortium, and browser developers are now implementing HTML5 features in their latest releases. This HTML5 page on Wikipedia provides a lot of good detail on features and functionality. HTML5 improves the ability of web-based applications to perform many of the functions that were previously only available to so-called native code apps, such as the Android apps we've used in this course. For example, HTML5 provides built-in audio and video support. Some developers believe that HTML5 can offer alternatives to having to develop multiple versions of an app for the different mobile platforms such as Android and iOS. In theory, web apps can be written once and run anywhere. There are, however, a couple of significant barriers to realizing this objective. The first is feature access. Not all mobile device features can currently be accessed from a web app. The second is performance. Mobile device processors don't match the power of desktop and laptop computers, so applications such as games that are computing and display intensive often won't run correctly on mobile devices, especially smartphones. So the current best solution to this dilemma is to use web app capabilities, when appropriate, to supplement native apps. Some apps might rely entirely on the web, some entirely on native code, and some on a mixture. So that's our overview of the chapter on web apps and HTML5. Now let's move on to the next lesson and look at some code.